Let us solve some problems on polynomials. Question number 1 says, find the value of a for which x minus 2 is a factor of 3x cubed plus ax squared plus x minus 2. So for this, as it is saying that x minus 2 is a factor of this, that means if I put x equal to 2 in place of all the values of x as 2, then I'll need the value of this as 0. So using the factor theorem, which says that if x minus a is a factor of some polynomial px, then pa will be 0, right? So what I need to find out here is just that p2 must be equal to 0, okay, according to factor theorem. So here, just put in place of x value of x as 2. So this is 2 cube plus a 2 square plus 2 minus 2, and this needs to be 0 according to factor theorem. Okay, so this is 8 into 3 is 24 plus 4 times a, 2 minus 2 is 0. This must be equal to 0. So here I get value of a as minus 6. Okay, this is your first part. Second part says that show that for this value of a, the cubic equation has only one real root. Means if I put this px as polynomial px equal to 0, then I will get an equation. So I have to use this value of a, which is minus 6, and then I need to find out the roots of this cubic equation, and then we have to show that the cubic equation has only one real root. By real root, we mean that other two roots of this cubic polynomial will be complex. As we have learned earlier lessons, that for a cubic polynomial, maximum real roots possible are 3. Okay, either it will have one real root or it will have 3 real roots, right? If it is having one real root, then the other two roots will be complex, means you cannot find any more real value for x. Okay, so first of all we need to use this value of a. So second part is that your polynomial px will now be 3x cube minus 6x square plus x minus 2. Okay, so first process is I need to factorize this. As it says that x minus 2 is one factor of this polynomial, so I can write this as x minus 2 multiplied by one quadratic factor. Why quadratic? Because the highest term here is of power 3, one linear term is here, so this has to be a quadratic polynomial. Then only by after multiplication of this x with x square I get x cube, right? Now how to find out this second factor or second polynomial? There are two ways. One is long division method that we have learned earlier in the theory part. Here I am using a shortcut method. Shortcut method means we'll just learn how we can find out this second factor. Okay, so look carefully. Here I have this x, right? And this x will be multiplied by some factor here. Okay, first factor. And this has to be a quadratic. This we already know, right? So if I just write here as x square, and after multiplying this x with x square, I will get x cube. But here in the answer I have 3x square. Okay, I cannot make any changes in x minus 2, right? So this has to be 3x square. Okay, you can check here that if this 3x square will be multiplied by this x, you will get 3x cube. Okay, fine, this term we obtain. Now next step is we will look at the constant term, this minus 2. The logic is that when this constant will be multiplied by constant, then only I will get a constant. Okay, if I multiply this minus 2 with this x square, I won't get any constant. If I multiply this x with this some constant, I won't get any constant. Okay, so this minus 2 has to be multiplied by some number here without any x term in order to get this minus 2. Okay, and this minus 2, if I multiply this by just plus 1, then only I will obtain minus 2. Okay, had it been, let us say, minus 4, so this minus 2 will be multiplied by plus 2, okay, in order to get minus 4. Okay, but the logic is that constant will be multiplied by this constant only in order to get this -2. And here in this case, we get this number as only +1. Fine. Now, if you look at it carefully, that I have obtained all these 4 terms just by writing these 2 terms. Okay, means this is a special kind of quadratic polynomial where there is no x term. There is no x term here. Okay, you just multiply this, you will get 3x cube minus 6x square, and here this is plus x. If I multiply this x with this plus 1, I will get plus x, and minus 2 I have obtained. Okay, so all the 4 terms are multiplied by this. I will obtain by multiplying this x minus 2 by just 3x square plus 1. Okay, so we have factorized this polynomial. Okay, and now if I have to find out the roots of this equation, now I put this equal to 0, I will get x minus 2 equal to 0, or this polynomial, quadratic polynomial, has to be equal to 0. This is the method that we use to find out the root of any 2 polynomials which are in multiplication. Okay, here I have x equal to 2 as a solution, and here 3x square plus 1 equal to 0. Now this 3x square, as this 3 is positive, this x square is positive, positive into positive will be positive. Okay, so this 3x square will always be positive, and this plus 1 is obviously positive. So what you are doing is that a positive is added to a positive term, which will give you a positive term, not 0. Right? If this has to be 0, that means one term must be negative, one term must be positive. Then only you will get an answer as 0. Right? If both the terms are negative, you won't get any positive 0. If both the terms are positive, then also you won't get any result as 0. Okay? So one has to be negative, one has to be positive. But here both the terms are positive. So what we conclude here, that this equation 3x square plus 1 equal to 0 has no real solution or no real roots. Okay, so for this cubic polynomial, I have only one real root, which is x minus 2. Okay, so what you need to write here is that as 3x square plus 1 is greater than 0, that means px has only one real root, right? That is x is equal to 2. This is your final answer. Okay, so in these type of questions where we have to see or we have to solve a cubic equation, what we need to find out is we have to do factorization of this cubic polynomial. Okay, after factorization we will equate it equal to 0 and find out the roots, right? If it is saying that it has only one real root, or it has only 2 real roots and other roots are complex, that means this second polynomial has to be a quadratic polynomial which has no real solutions. Okay, fine. Let us take second question. It says that first part, we have to show x minus 3 is a factor of x cube minus 5x square minus 2x plus 24. It's very simple that using factor theorem, if I have to say that x minus 3 is a factor, that means by putting x equal to 3, I should get the value of the polynomial as 0. Okay, so if I have been given this px, which is x cube minus 5x square minus 2x plus 24. Okay, so I need to find out this value, not p2, it is p3, because x minus 3 is a vector. So if I find out p3, which is 3 cube minus 5 into 3 square minus 2 into 3 plus 24. Okay, this is 27 minus 9 into 5 is 45 minus 6 plus 24. Okay, so this is minus 18 and this is plus 18, which is 0. So first part answer is that since p3 is 0, this implies Hence, we can say that x minus 3 is a factor of px. Okay. Let us see what this second part says. Second part is, hence we have to solve this equation. Okay. Since we have shown that x minus 3 is a factor of this, and in this second part we have to solve this cubic equation. So as we did in the previous question where x minus 2 was given as a factor and then we factorize the polynomial completely. Okay, so same process we will do in this part also, that we will factorize this px completely where one factor is given as x minus 3. Okay, so I will write this as, this is 24, x minus 3, as x minus 3 is one factor. I need to find out this factor. Okay, as in the previous example I told you that there are two ways to factorize this. One is division method, long division method, and another is this direct method. Okay, we just have to look carefully the terms. Okay, so I need, this has to be a quadratic factor because this is linear. First thing is this, right? So there will be some x square. How much x square will be there? That is determined by this leading coefficient of x cube. Okay, since this is only x cube, this is x, so it is just x square, right? When x is multiplied by x square, you will get x cube. Okay, simple. Then third step was to look at this constant term 24, right? When this minus 3 will be multiplied by minus 8, then only you will get this plus 24. Right, constant will be multiplied by constant, then only you will get a constant, and that is in this case minus 8. Okay, now comes this, either you look for x term or you just look for x square term. Okay, let us look at x square terms. Now there are two ways in which we can get this x square term. One is that if I multiply this minus 3 with this x square, I will get minus 3x square. Okay, and second is when I multiply this x with this required x term, I will get another x square. Okay, when this minus 3x square plus some coefficient of this x square, then only you will get the total x square terms, which in this case is minus 5. Okay, so I need another minus 2 in order to get minus 5x square, because minus 3x square is already here. Okay, so I need here minus 2x, right? So just write this minus 2x, right? We can check here that if I multiply this x with this x, I will get minus 2x square, and when this minus 3 multiplied by this, you will get minus 3x square, so minus 5x square. Okay, so you will say that what will happen this to minus 2x? It will automatically be adjusted if this polynomial, if this px has to be factorized completely. One factor is x minus 3, then this will get automatically adjusted. Okay, so you can check here. Okay, total x term are just minus 2x, so x term will be minus 8 and this plus 6, minus 8x plus 6x will be minus 2x. Okay, so hence we have factorized this completely. I can write this as cleanly that this is x minus 3, this is x square minus 2x minus 8, and again this quadratic factor can be factorized into two linear factors. Okay, I can factorize this as x minus I think 4, and this is x plus 2. Okay, x square minus 2x minus 8. Okay, so now this polynomial is now completely factorized into three linear factors, and if I have to solve this equation, I will get three linear factors: x minus 3 equal to 0, then x minus 4 equal to 0, and lastly x plus 2 equal to 0. So I will get three roots of the cubic equation. One is 3, 4, 3, 4 and minus 2. Okay, so these are the three roots of this cubic equation. Okay, now third part says that hence we have to sketch the curve x cube minus 5 square minus 2x plus 24. Okay, once you are able to find out the points of intersection of a curve with the x-axis, that means you can you can roughly sketch the shape of the curve. Okay, it is not asking that we have to draw the graph of this. It just says that we have to sketch the curve. Sketching means you have to locate the y-intercept, the shape of the curve should be correct, and it should shows the point of intersection of the curve with the x-axis. Okay, means roots we have found out just yet. Okay, so third part is sketching the curve. So let us sketch the curves. I have this as my y-axis. Let us say this is my x-axis, right? And this is y, this is x. Okay, and now these are the point of intersection of the curve with the x-axis. So just locate this -2 here. If this is -1, let us say this distance is -2, and this is 3, and this is, let us say, 4. Okay, these are the points of intersection of the curve with the x-axis, means these are the roots of the equation px equal to 0. Okay, now I have this polynomial, which is, let me write down this polynomial again, or it is just written here, you can refer to this. Okay, so here if I put x equal to 0 means y-intercept, I will get y-intercept as just 24. Okay, so let us locate this point 24 also. Roughly, let us say this distance is 24, although the scale is not matching of x and y axis, but let us suppose this point is 24. Okay, now there are two possibilities for this cubic equation. One is that either the graph can start from this plus infinity, means from the second quadrant, intersect at this -2, again at +3, and again at 4, and it will go downward like this. Or second possibility could be that it start from -infinity, intersect at -2, then again intersect at 3 and 4, and so on. It will increase to +infinity. Okay, so we have to choose between these two possibilities. One method could be that since the y-intercept is +24, right, in this case there is no y-intercept which is positive, it is negative, so we rule out this possibility, and this is the required curve, means the shape of the curve will be like this. Okay, so let us draw the shape of this, that it will start from -infinity like this, intersect at -2, then y-intercept is +24, then it will come down to x equal to 3, then again it will bend between 3 and 4, and again intersect at 0.4, and it will increase to +infinity. Okay, so this will be the shape of the curve. Okay, it is not looking nicely. My drawing skills are not so good, so you just manage it that it is like this. Okay, it is a continuous graph. It is not, it is not a corner, it is a smooth curve. Okay, let us do one more question. Question 3 says that the polynomial this, where a and b are constant, it is denoted by px. It is given that 3x minus 4 and x plus 2 are the factors of px. We have to find the values of a and b. Okay, this is a cubic polynomial and two linear factors are already given, right? That means if two linear factors are given, we can say that if I put 3x minus 4 equal to 0, that means x I obtain as 4 by 3, and if I put x plus 2 equal to 0, I get x as minus 2. So that means x equal to 4 by 3 and x equal to minus 2, these are two roots of the equation px equal to 0. Okay, if these are the factors, that means 4 by 3 and minus 2 are two roots of the equation px equal to 0. That means these will satisfy the given polynomial or given equation px equal to 0, right? So first I will put x equal to 4 by 3 in the given polynomial. I will get an equation in a and b. Then again I will put x equal to minus 2 in the polynomial. I will get another equation in a and b. And since there are two variables, two unknowns in the equation a and b, which we have to find out, that means we need two conditions. Okay, two variables, two conditions we need to get at least to solve or to find out the values of a and b. Okay, so let us put p px we put, let us say, x equal to 4 by 3. Okay, so basically p 4 by 3 we are finding out, and this has to be equal to 0, right? Because this 4 by 3 is one solution of, or one factor. 3x minus 4 is one factor, so 4 by 3 will be the solution of this equation. So this p 4 by 3 must be equal to 0. Okay, so this is 3 into 4 by 3 cube plus a times 4 by 3 square plus b. Okay, this must be equal to 0. Let us simplify this. It is 4 cube is 64, and this is 3 square, so 64 divided by 27, 3 by 27 is just 9. Okay, plus this is 4 into 4, 16, and this is by 9. Okay, so 16a by 9 plus b, this is equal to 0. Let us simplify this. I get simplified form as 16a plus 9b is equal to minus 64. Okay, this is your equation number 1. Now by putting x equal to minus 2 again, so I will find out p minus 2 equal to 0. That means 3 of minus 2 cube plus a times of minus 2 square and plus b. This also has to be equal to 0. So this minus 2 cube is minus 8 into 3 is minus 24. This is plus 4a plus b equal to 0, or 4a plus b is equal to 24. Okay, this is your equation number 2. Okay, so I can again write equation number 1 below this, so I can solve this easily. 16a plus 9b is equal to minus 64. Okay, this was your equation number 1. Now we have two equations, two variables. Let us solve these by elimination method. If I multiply this equation 1 by 4 and then subtract equation 1 from equation 2, I will get minus 5b is equal to 24 into 4 is 96, and minus 64 is plus 64. Okay, so minus 5b is equal to 160, I think. So value of b is 160 divided by minus 5, which is minus 32. Right, this is your value of b. Now putting this value of b again either in equation number 2 or equation number 1, I can obtain the value of a as 4a plus b is equal to 24. That means 4a is 24 minus b means plus 32, which is 56. So 4a is 56, so value of a is 14. Okay, so a is 14, b is minus 32. Okay, you can look again at this solution. All right, so I think these are the kinds of question that you will get in the chapter polynomial, where we did in the first question that we have to determine whether the cubic equation has some complex roots, or we have to show that it has only one real root and two other roots are non-real, or they are complex. And second, that in the second type of question we have to find an unknown from the equation, from the polynomial, and then we have to find out the other roots, and then we have to sketch the curve. And sometimes there will be two unknowns in the polynomial, so there will be two conditions given. In this case, it has been given that these two are the factors. Question could be like that, it might be given that let us say 3x minus 4 is one factor, and x plus 2, if the polynomial px is divided by x plus 2, you will get some remainder. Okay, here we have used both the conditions we have used for factor theorem. but sometimes we may use the remainder theorem and we may use the factor theorem combinedly. Okay, question could be like that also. All right, thank you.